This is the Unit 9 test review for Honors Math 2. And number 1, we're looking for the arc length of the circle. The measure of that arc is 120 degrees. The radius is 9 inches. And so we're looking for a fraction of the whole circumference. And the fraction is 120 over 360 times pi r squared. Sorry, times 2 pi r. And r is 9. So the 2 pi r, or the 2 pi 9, is our circumference, and then the 120 over 360 is the fraction of the circle that we're working with, which can reduce to 1/3 times 18 pi, and 18 divided by 3 is 6, so we're going to leave it 6 pi, and we're talking inches. Sorry, this is not area, this is just inches. This is a one-dimensional unit. And that's our answer, 6 pi inches. Number 2, we're looking for it tells us the arc length is 2 pi. And the measure of the arc is 36 degrees. Find the radius of the circle. So we know that 36 divided by 360, that's the fraction of the circle, times 2 pi r is equal to 2 pi. If I divide both sides by 2 pi, I get 36 over 360 times r is equal to 1. If I reduce that fraction, I get 1 over 10. R equals 1. And then multiply both sides by 10, you get r is 10. And it doesn't give us units, so I'm going to say 10 units. Number 3, we're finding the area of the sector of the circle. Notice it's 90 degrees, so the fraction of the circle is 90 over 360, which is a quarter of that circle. And we're looking for the area, and the area of a circle is pi r squared. So pi times 4 squared. So we got 1/4 times 16 pi. Divide 16 by 4 and you get 4 pi. And we're looking at units squared, because that's area. Number 4, the area of a sector is 3 pi m squared, or meter squared, and the area of a circle is 15 pi. What's the measure of the central angle? So let x equal the measure of the central angle. Then x over 360 times the area of the circle, which is 15 pi, is equal to the area of the sector, which is 3 pi. And we can reduce our fraction. We got 15 over 360 reduces to 1 over 24. So we could write x over 24 pi is equal to 3 pi. We can divide both sides by pi and get x over 24 is equal to 3. And then lastly, we can multiply both sides by 24 and get x is 72 degrees, because that's the measure of the arc, or the central angle. Number 5, the circumference of a circle is 8 pi. So we know that 2 pi r is 8 pi. If I divide by pi and divide by 2, I get the radius is 4 centimeters. Now I want to find the area. The area is pi times r squared, which is 16 pi, and we're looking at centimeters squared. Number 6, we have a square 4 by 4, and the area of that square is 4 times 4, which is 16 square inches. And then we have two semicircles that make a full circle. And so the area of that full circle is pi r squared. R is half the diameter. Diameter is 4, so pi times 2 squared, or 4 pi inches squared. And so the shaded area is the square, the area of the square minus the area of the circle, so 16 minus 4 pi. And that's square inches. Find the area of the shaded region here. It's the area of the sector. So the area of the sector is 120 over 360, which is 1/3 of that circle, times pi r squared, and that's 1/3 times 4 pi, or we could write 4/3 pi. The area of the triangle, well, it's isosceles. This is 2 meters as well. Central angle is 120 degrees. If I drop an altitude here, I get a 90-degree angle here, and I cut that 120 in half, so that's 60. This is 30. And so we have the 30, 60, 90 right triangle. Your longest side is always your hypotenuse. Your shortest side is always half the hypotenuse, so the height of that triangle is 1. And then the medium sized, or the side across from 60, is the shortest side times root 3. So this is, oops, lost it. So this is root 3. And so the area of the, or the base of this full triangle is 2 root 3. So area is 1/2 base times height, which is root 3. And so the area we're after is the area of the sector minus the area of the triangle. And that's 4/3 pi minus the square root of 3 meters squared. Eight, we have a triangle. We need to, it's an equilateral triangle, so all sides are the same. And we know that the radius, the distance from the center to a vertex, is 8 inches. And we want to find the side length of this. So we've divvied up the center, which is 360, into 3 equal parts. So we have 120 degrees on each angle. If we draw the altitude, we get a 30, 60, 90 with a hypotenuse of 8 inches. So the shortest side is the apothem, or the distance from the center to the midpoint, and that's 4. And then the side across from 60 would be 4 root 3. So the full side length would be double that, which is 8 root 3 inches. Finding the area of a regular hexagon with a perimeter of 96. If the perimeter is 96, then the side length is going to be 96 divided by 6, because it's a regular hexagon. Each side length is the same, and there are 6 sides, and so we end up with each side being 16. So from that center, if I draw this triangle, we know that central angle is 60 degrees, and we know it's isosceles, so we have an equilateral triangle, 60, 60, 60. Each side length is 16. If we cut that equilateral triangle in half, we get a 30, 60, 90. I'm going to move it over here, where the base of this would be half of the 16 because I'm cutting it in half. The hypotenuse is double that, which we knew that was 16, and then this side is 8 root 3. So the area of this piece is going to be 1/2 base times height, which is 32 root 3. And this our hexagon can be split into 12 of these triangles. So 12 of the right triangles, 6 of the equilateral triangles, but each equilateral triangle is 2 of these right triangles. And so I could, so the area of the hexagon is 12 times 32 root 3. 32 times 12 is 384 root 3, and we're looking at, doesn't give us the units, so I'll just say square units. Number 10, we're asked to find the volume of this triangular based prism. The base of the prism is going to be perpendicular to the height, and the base of the prism stays the same no matter where, what kind of cross section you cut. So I'm going to color in the base of the prism here. It would be this triangle. Because if you slice this object, say I slice it right here down the middle, it's going to be, you're going to get the same shape no matter where that is, so it stays consistent all the way through. And so we, so if all the areas of each of those cross sections remain the same, you've located the base of that prism. So the base of the prism, or the area of the base, is going to be 1/2 the base of the triangle, which is 35, times the height of the triangle, which is 7. And then we want the height of this prism, which is 18. And so putting this together, the volume is equal to the area of the base of the prism times the height. And here we get 2,205 cubic millimeters. Number 11, we're told that the volume of this triangular base prism is 36 cubic centimeters, and we want to find x, which is our height. Okay, again, we know that I'll color in the volume here. We know this triangle right here is our base, because no matter how, all cross sections will form that same triangle. If I cut it in the middle or at the end, it remains constant. And so our volume, 36 cubic centimeters, is the area of the base, which is 1/2 times base times height of the triangle. So this is the area of the triangle, or the area of the base. This is the volume of the prism. And now we have the height, which is x. So 36 is equal to 9/2 times x. I'm going to multiply both sides by 2 and get 72 equals 9 times x. Divide by 9, and you get x is 8 centimeters. For 12, we have a cylinder, and we're looking for the radius. So our volume for the cylinder is given at 602.88, and that's equal to the area of the base, which is pi times r squared, or which is x in this case, times the height, which is 12. So if I divide both sides by 12 pi, I get, let's see, 602.88 divided by 12 pi is roughly 16. So this is an estimate, so roughly 16. So we get x squared is 16. Take the square root. We get, could be positive or minus 4. We're going to go with the positive because we're talking about a distance here, and we're looking at centimeters. 13, we have a rectangular prism with a cylindrical hole through the middle. And so the volume of this will be equal to the volume of our prism minus the volume of our cylinder. And so the volume of the prism is the length times the width times the height. Sorry, that should be a 10 times 8. The volume of the cylinder, it's hard to tell from the picture, but it looks like that 4 is our diameter. And so the radius would be 2. And so we have the volume is pi r squared, so pi times 2 squared times the height, which is 18. So this is 1440 minus 72 pi. And we're looking at cubic inches. Number 14, we have a hexagonal based pyramid. And so we know that the volume of this is 1/3 the area of the base times the height. So we know that the height is 5, and we need to work on the area of the base. So for the base, we have this hexagon. Should be a regular hexagon. And the apothem is given, oh no it's not, so find the volume with side length is b. Okay, so side length is 9. So each of those. So we're going to look at this right triangle here, because we can divvy this into 12 of these triangles, 12 of these right triangles. In that right triangle, the base is going to be half a 9. It's a 30, 60, 90. This is going to be 4.5 root 3 for the height. And so the area of that triangle is 1/2 times 4.5 times 4.5 root 3. I'm going to get an approximation for that. So we get roughly 17.5. I'll use that. And so now plug that into the volume formula. 17.5 times 5 divided by 3. So again, about 29.2 cubic units. We have a cylinder. Looks like the radius of that base is 2 and the height is 10, so pi, so the volume is pi r squared times the height. So that's 40 pi cubic millimeters. 16, we have a cone. The volume of a cone is 1/3 the area of the base, so pi r squared times the height, h. Be careful here, 5 is not your height. 5 is called the slant height. The height of the cone has got to be perpendicular to the base. So that's this piece that I traced over, and it's you got a right triangle. You can use Pythagorean theorem, h squared plus 4 squared equals 5 squared. Or you may recognize this as a 3, 4, 5 right triangle. And you get the height is 3. So the volume is 1/3 pi times 4 squared times 3, which is 16 pi cubic centimeters. We have a square base pyramid with a base edge of 8. Again, the volume is 1/3 area of the base times the height. And area of the base is pretty easy. It's a square base, 8 by 8, so that's 64. But the height is not apparent yet. We have the slant height of 10. The base of this right triangle here is half the length of the square, so it's 4. And so I'll call the height h and use Pythagorean theorem. 4 squared plus h squared is 10 squared. So h squared is 100 minus 16, which is 84. So the height is the square root of 84. I'm going to approximate this. So it's roughly 9.2 centimeters. And then we get an approximation again for the volume. Which is roughly 195.5 cubic centimeters. 18, we want the diameter of a sphere given a volume. So the volume of a sphere is 4/3 pi r cubed. And the volume is 2304 pi. And so we can solve for our radius here. If I multiply by 3, get 2304 times 3 is 6912. Pi is 4 times pi times r cubed. Divide by pi and divide by 4. And we get r cubed is 1728. Take the cube root of 1728 and you get 12. So we have a radius of 12 centimeters. But that's not what we were asked to find, so go back to that question. We were asked to find the diameter, which is 2 times the radius. So the diameter is 2 times r, which is 24 centimeters. Sphere A has a radius of 2. Sphere B has a radius of 4. How do the volumes compare? So volume for sphere A is 4/3 pi times 2 cubed. Whereas volume of sphere B is 4/3 times pi times 4 cubed. Sorry. And if we compare these volumes, let's say the larger to smaller, I'll put it in a ratio form. So 4/3 pi times 8 compared to 4/3 pi times 64. You can divide both sides by 4/3 pi. You could divide both sides by 8, and you end up with 1/8. So how do their volumes compare? We can say that the volume of sphere A is 8 times smaller than the volume of sphere B. Number 20, we have a spherical scoop of ice cream with a diameter of 4 centimeters that rests on top of a sugar cone that's 10 centimeters deep and has a diameter of 4 centimeters. If all the ice cream melts into the cone, what percent of the cone will be filled? So first of all, we'll do the volume of the ice cream. It's got a radius of 2 since the diameter is 4, and so you have 4/3 pi times the radius cubed, which comes out to be 32 pi over 3 cubic centimeters. Now the volume of the cone is 1/3 pi times the radius squared times the height, which is 10, and that comes out to be 40 pi over 3 cubic centimeters. So what percent of the cone will be filled? So in other words, what percent of the volume of ice cream is the volume of the cone? To get this, we're just going to go volume of ice cream divided by the volume of the cone, which is 32 pi over 3 over 40 pi over 3. Multiply top and bottom by 3 to reduce this or simplify the fraction to 32 pi over 40 pi. Divide by pi, and we can also divide by 8. So let's divide top and bottom by 8 pi. You end up with 4/5. Which is 0.8 or 80%. So what percent of the cone will be filled? 80% of the cone. Number 21, I want to find the value of x. We have a triangular base prism. So here we know that the volume is the area of the base, so 1/2 base times height of the triangle times the height of our prism. And we're given the volume at 980. 1/2 we could say, if we let the base of the triangle be 14 times the height of the triangle, which I'll label here, times the height of the prism, which would be 20, we end up with 980 equals 140h. Divide by 140 and we get the height is 980 divided by 140, which is 7 millimeters. Now in this triangle, where the base is 14, if we cut right down, draw the altitude, we form a right triangle, and the hypotenuse is x, and we know the height here is 7. And there's an issue here because we don't know if that 14 is cut in half or not, because we're not given some angle measurements. If this was a 45, 45, 90, then we would know how it's split, or if it was a 30, 60, 90, we might be able to use some of the patterns, but we don't have enough information. This is as far as we can go, and on this particular problem we can't solve for x. Number 22, there are two cans, one tall and one short. So here's one tall, one short. If the area of the base of both cans is 2 pi, so B is 2 pi on this one, area of the base here is also 2 pi. The volume of the tall can is 18 pi. So 18 pi equals 2 pi times the height of the can, which tells us the height of the can is 9 centimeters. The short can is 3 centimeters shorter, so the height of this shorter can is 6 centimeters. What's the volume of the shorter can? The volume is going to be 2 pi, which is the area of the base, times the height. So we end up with 12 pi cubic centimeters. 23, we have a square inscribed inside a circle. So here's my square inside a circle with a diameter of 14. So there's the diameter of the circle, also the diagonal of the square, which is 14. What's the area of the square? We have a 45, 45, 90 right triangle. And in general, we know that these are isosceles. And whatever those leg lengths are, the hypotenuse will be that times the square root of 2. So if I say x root 2 equals 14, and solve for x, I end up with x is 7 root 2. And so for the square, we have a 7 root 2 by 7 root 2. So the area is 7 root 2 times 7 root 2, because those are the side lengths of the square, which is going to be 7 times 7 is 49. Square root of 2 times square root of 2 is 2. So 98 square meters. 24. The radius of a sphere is 12. Find the volume. So the volume is 4/3 pi r cubed. And that comes out to be 2,304 pi cubic centimeters. 25. The diameter of tennis balls is 2.7 inches. You want to create a cylindrical tube that holds 4 balls perfectly. So the height of the tube we need to find. Well, if the diameter is 2.7 and you want 4 balls, so you're going to go 4 times 2.7 for the height of the tube, which is 10.8 inches. The volume of the tube, well, the radius of the ball will be half of 2.7, and that is going to be 1.35. So the volume is going to be pi times 1.35 squared times 10.8, which is approximately 61.84 cubic centimeters, or no, sorry, cubic inches. The volume of one tennis ball is 4/3 pi times 1.35 cubed. And that is about 10.31. The volume of the extra space in the tube not used by the balls. So the volume of the tube is 61.84 minus the volume of 4 balls, so 4 times 10.31. This is approximation. That comes out to be 20.6 cubic inches. And that's the end of the review.